Welcome! In this third clip of the hydrogeology block, I want to briefly mention 3 hydrogeological case studies. I do this to address a few major challenges associated with water exploitation and with your future work as geologists. These challenges refer to phenomena taking place in the coastal domains, to the hydrogeological consequences of long-term changes in the amount of precipitation, and to the interactions between water flow and pollution. I'm sure that quite a lot of you live in areas where one at least of these challenges is real. The coastal domain is a region where fresh water, typically carried by rivers, come in contact with marine waters. Because of its low density, fresh water will tend to remain close to the surface and will overlie the body of marine waters, which is characterized by higher density. The 2 bodies of water will be separated by a relatively thin transition zone. The position of the fresh salt water transition can be clearly defined, for instance, by measuring chemical elements such as chlorine in the underground waters. On average, besides smaller seasonal oscillation, the position of the fresh salt water contact is fairly stable. At longer timescales, that of tens of years, things might be different in relationship with decrease in precipitations predicted by some climate change models. Not surprisingly, human intervention can have a major impact on the position of the transition zone and therefore on the quality and quantity of water supplies in the coastal domain. If much more water is extracted than what can flow into the aquifer, then the water table will descend, and maybe more importantly, the fresh salt water transition will rise and eventually might reach the bottom of the well bore. Salt water will start entering the well. And this is not the end of it. The entire sediments around the well bore will be polluted by salt, making it difficult to have clean water again, even in the case that pumping decreases. Absolutely not a remote possibility, as coastal domains host, for instance, some of the largest cities in the world. We have seen in previous clips that the climate we enjoy at present is a very different one from the one dominating the world something like 10,000 years ago. In areas such as North Africa, precipitations were more abundant and giraffes and other animals were less scarce than at present in mountains like the Hogar and Tassili massifs. The waters have been flowing along excellent aquifers such as that in the Nubian sandstones and are now abundant in the subsurface of countries like Algeria and Egypt. Indeed, plans have been made and partly implemented to tap into these huge amounts of high-quality waters. The Great Man-Made River Project is one of those. Clearly, these are phosphorus water, which implies that the aquifer is not being recharged at rates that they are extracted. This has sparked many discussions, but how long will it take to cause a significant decrease? If this is in the order of hundreds of years, is it acceptable, seeing also dramatic present-day challenges? A further and very exciting feature is related to the consequences of the low sea level present during glacial times. Fresh water was then carried by waters across large portions of the future continental shelf. When sea level rose, the coastline retreated, leaving a lens of fresh water underneath the shelf. In the example of the New Jersey coast gives you the idea of the large amounts of fresh water involved in this process. Pollution is clearly one of the major threats to the quality of our water supplies. Contaminants can enter the groundwater from point source, such as leaks from tanks, to non-point sources, such as landfills. Contaminants may stick to the grains, remain in the groundwater because they flow less easily. On the other side, flowing has also the positive effect because it allows filtering of the waters, especially if flow is slow enough. This is an effect exploited among others in the Netherlands, where water is pumped in sands in the dunes north of Amsterdam and then extracted clean and nearly ready to be used. Herewith, we have come to the end of the clips dedicated to hydrogeology. This is an exciting science and one of great social importance in which geologists will play a great role.